Hi everyone, welcome to the Testing Fundamentals Introduction Part 2 session. In the last session we covered why testing is necessary and what is risk-based testing. Just to go through the contents of this training session, why is testing necessary and testing techniques as well. In testing we always have a limited amount to test, right? And you have to use risk to determine what you want to test, what is the most important, and how thoroughly to test. And thereafter you also have to decide what not to test, right? And allocate the time which you have to the amount of testing which you need to do. And you do that by prioritizing what functionalities you're going to test at this point of time. So risk-based testing is the decision of where to place emphasis in testing, that is what to test first, what is the most important to test, and how thoroughly you want to test each and every functionality. The most important principle for testing is that since you always will have a limited amount of time, you need to prioritize tests. So when you decide that we have done enough testing and we are stopping to test further, you will have done the best possible testing in the time available. So you are prioritizing the most important tests first, and thereafter towards the end of the cycle you will be leaving out the functionalities which you don't think are most important as of now or at this moment of time, right? So quality and testing are used quite commonly in the software testing industry. So testing measures software quality. You find faults through testing, and when you remove these faults that you found through testing, the software reliability is improved. That's what we discussed in our previous training session as well. And just to recap, what does testing ensure? It ensures that the system functions correctly and the functional flows and the entire functionality of the system is as defined by the client requirements. Apart from this, you also test for usability, that is ease of use by end customer and other factors like performance. Okay, there are many types of testing which we will be covering over our future training sessions as well, but just to list a few, they are black box testing, white box, regression, ad hoc, smoke, load, and security testing. We will be covering each one of these in the future training sessions as well. Now SDLC is a very common concept in testing and development as well. So SDLC is the software development life cycle. Okay, what is the life cycle? Let's go through that. It starts from gathering requirements from the end customer, then analyzing those requirements and creating use cases or functional flows from there, designing your system as to how it is going to work, which modules will be designed first, what is the impact of each module on the other, the dependency, and then actual coding of all the modules, thereafter testing, and then implementation and maintenance after the system goes live into production. Sorry. So we have to figure out, does testing begin only in the sixth step as mentioned in the slide here? No, it doesn't. Where should it begin? If we begin testing later, in the later stages, as we discussed in our previous training session, the cost of fixing a failure will be very high, right? So obviously you have to test earlier. Now where? Let us think about that. When should testing start? Obviously testing has to start in the requirement phase. So it starts from the beginning, and testing and development have to go hand in hand to develop a good, reliable end product. So this is the testing life cycle, which is project initiation, system study, test planning, then designing the test cases, executing test cases, then reporting defects, regression tests, which we will be defining later, which means that you are figuring out how the system is performing after some fixes, analysis, and final summary reports. This is the testing life cycle, right? So test life cycle, that was a graphic representation. This is step by step, which is SRS, system requirement specification document preparation. You create a test plan as to how you're going to test, how many people, what's the timelines, what kind of milestones do you have, what is the exit criteria, what is entry criteria, etc. Then design test cases based on your test plan and the system requirement specification, execution of test cases, evaluation of the execution and the results thereafter. You document those test results, you prepare reports and follow up or regression testing on reported bugs. Now, there are different levels of testing which we need to understand. One is unit, second is integration, third is system, fourth is acceptance. This is a very broad guideline for levels. Unit is with respect to the code, which at the level of coding, at the level each individual program, there is unit testing done. Then you integrate, say, 2 modules or 3 pieces of code, and then you do integration testing. Then you have system or functional testing, wherein you go through end-to-end functional flows and test it, and acceptance is the final testing in the production environment, before the production environment, which is to find out if your system has performed as per requirements. Now, since we're talking of testing, we must ask this question: who is a good tester? Okay. Now, a developer creates the code in a specific logic based on the design. All developers wouldn't know all the entire functionality as a whole. As a tester, we need to understand the entire functionality. We need to look at a system in the end-to-end flow as a user or an end user will look at it. So we need to have a test to break attitude. That is, you should be able to analyze the system from the point of view of a customer and figure out bugs from there. So, and you also need to have an attention to detail, right? Let's get to the next important topic here, which is testing techniques. There are 2 concepts here, which is verification and validation, right? So, what is verification and what is validation? We need to define that. Verification is a process where you check if the software is conforming to the requirements or the specifications which you gathered in the requirements phase. So you have reviews and meetings to evaluate documents, plans, requirements, and specifications. Validation is a process where you check if the software meets customer requirements. So you actually test at the user end, and you validate if the application is meeting customer requirements. Verification types, which is reviews, walkthrough, and inspection. There are 3 types of verification which can be done. One is review, one is walkthrough, and one is inspection. Verification, what do you look for? You find all the missing information in your specifications, in your documents, and you review, right? So you find information which is who, what, where, when, and why. These are the questions which you need to ask when you are doing verification. The second method is peer review. So you give a document to a colleague and ask them to review it as a third party and find defects which we will never find out on our own. That is called peer review. Walkthrough. Walkthrough is an informal meeting where you have a group of participants who come to a meeting and the author gives the presentation. The objective is to detect defects and everyone else becomes familiar with the material of that meeting, and the end result of this walkthrough meeting is a defect report, wherein the author actually is the presenter and he walks through everyone through the functionality of his piece of code or his piece of work, and the other participants review. Inspection, which is a formal meeting, and every participant does some preparation before attending the meeting. The objective is to collect data, discuss about important work product information, find defects obviously, and there is a moderator for such a meeting and ensures that rules are being followed and the review is effective. Okay, we defined what is validation earlier. So the two main strategies for validation are white box and black box testing, right? So the main difference between verification and validation is what we have covered so far. For verification, there are three types of verification. So we've covered those as well. Now for validation, there is it's called a verification validation testing model, which I will take you through right now. So you need to understand and the difference between verification and validation in that model. That's the most widely accepted software testing model used in the industry. Right, so this is the V model with the most widely accepted testing model used in the software industry. So we can see the development life cycle, which we have discussed in the previous slides. So here it is requirement analysis, system design, architecture design, module design and coding, right. So this is on the left hand side, and this is how. So you start from coding, you do model design, you do architecture design, right. So the software development life cycle starts from requirements analysis, then you create the system design, you create architecture design, then you do module design and coding. So from coding you get into a unit test design and you do unit testing. You do from module, then you reach module design and you do integration test design and do integration testing. From there thereafter you reach system test design and system testing, and finally the acceptance test design and acceptance testing. So for every phase in the software development life cycle, you have a corresponding activity going on in testing. So both of them happen simultaneously. So it is not possible that you start testing after coding is done and then you figure out defects, and suppose after coding in your testing phase you find out defects which are related to say requirements or system design. The cost to fix such a defect is going to be very high. So if you see this model, so for requirements analysis you have for each and every phase you have a test designing happening over there. So you have requirements analysis and you have acceptance test design, you have system design going on, you have system test design, architecture and integration test, you have module and integration test design, and you have for coding, after coding you do unit test design. So these are parallel phases which run across development and testing. Both of them have to go hand in hand to test effectively and ensure that the end software product is reliable. Coming back to an example about defects and how important it is to figure out defects in the application, there is a true story about a Mercury spacecraft, which is there was a computer program which contained the following statement in Fortran, which is a programming language. So it says .do 100 I equal to 1.10. So the programmer's intention in this program was to execute a set of statements after this statement up to 110 times, and then creating a loop wherein the integer variable I was using the loop counter and starting in 1 and ending at 10. However, when the code was written, what happened by this statement was that the variable value of I became 1.1. Okay. So, and it did it only once. Therefore, the remaining code was executed only once and not 10 times as the programmer intended to do